Okay, this review is mostly conic sections, so parabolas, ellipses, circles, and all that jazz. I think I just left out hyperbolas actually. So most of this review is going to be over those, how to graph them or how to write them and things like that. But the first couple and the last few are related to systems of equations and matrices. So if you aren't interested in those and want to skip ahead, you can. And if you need to watch these to get a refresher on this kind of stuff, then go for it. So on 1 and 2, we're solving systems. Number 1, the equal signs means that we're not going to have to shade. We're just going to write where these intersect. And I'm going to use slope-intercept form to do this. Slope-intercept form is y equals mx plus b. The b is where you're going to begin on the y-axis, and the m is where you're going to move from there, and it's the rise over the run specifically. So this first equation, we start at -3 on the y-axis, and then we draw up 1 and over 1 because in front of x there isn't anything, which makes it a 1, and as a fraction that would be 1 over 1. So we're going to draw points and then draw our line. The more points you draw, the less likely you'll have to go back and add more points later. Or if you draw your line pretty straight, which I did not because I'm drawing on a tablet with my computer and that's difficult, yeah, just do the best you can. The next line that we have, -6x plus 4, starts at 4 on the y-axis, and then our slope is going to be -6 over 1, so down 6, right 1. And usually, unless your teacher is really trying to trick you, you should be able to find a place that they intersect nicely. If you're drawing by hand at least, instead of using the calculator, it should intersect someplace nicely like this. And so your work for this problem is this graph we drew, which hopefully your lines are straighter than mine. But our answer to this is going to be this point where they intersect, which is at 1, -2. And so make sure you don't forget that part, that we do have to actually write down an answer. Number 2 is different because we've got inequalities. So with inequalities, if there is an equal sign underneath, then that is a solid line. If there's not, that's a dashed or dotted line. If it's less than or equal to, you shade below. If it's greater than or equal to, you shade above. The other thing that you have to remember is if you divide by a negative number of some sort at any point while you're solving for y, you would have to switch the inequality around so it faces the other way. So that's the rundown, and so if that's not enough for you to be able to graph these and that's what you're looking for, look for another video that'll give you more detail and more examples. But we need to subtract x over to the other side to start, because right now it's a positive x, so that makes it 2y is less than or equal to -x minus 4, and then we want to divide by 2, which gives us y is less than or equal to -x over 2 we can write as -1/2 x, and then -4 over 2 we can divide and get -2. If we decide to just graph this line first, we start at -2 and we go, since it's -1/2, you either go down 1 and right 2, or you go up 1 and left 2. Only one of them gets the negative, either the top or the bottom, or both, or you can go both ways, I mean, so that you get more points. And so here is our line. It is a solid line because it has an equal to, and then less than this line is below this line. Now if you're ever not sure where below is, if you put your pencil on the line and draw an arrow down, whatever side of the line that you just drawn on, that's below. So this up here above the line, we don't have the arrow on that side. Down here is less than. If we were only graphing this line and not two lines, then this would be our answer, is this shaded region. But what we'll need to do is graph the other line now and then figure out where the shading overlaps. So I'm going to graph this other line. First we need to subtract 3x so we can solve for y. Y is less than or equal to -3x plus 3. So we're going to start at 3 and then go down 3, right 1. Because if it doesn't have a fraction, you just put it over 1. And so these do actually intersect at a point, but we don't need to know where they intersect. We just need to think about where their shading overlaps. That's a really bad line, just please forgive me. So less than on this line is a little bit trickier. Like you may have thought the first way was obvious, but here you may need to try that trick. Put your pencil on the line and then draw straight down. Since it's less than, which side of the line did you draw on? It should be this left side. And so this shading is on this side of our purple line. When you're doing this, if your teacher's okay with it, it might help you to use different colors. Otherwise, you can shade all of this, and then if your teacher's fine with it, what you can do is shade just the answer region, which is where it overlaps. We'd shade this part the darkest so that you can see that that's the answer. But what would actually probably be better, and my shading looks a lot better when I'm using pencil and not a computer, the best thing to probably do, especially if you're in a college class doing this, like college algebra, is to go ahead and erase, well, this is interesting, erase what you don't need. And so this is the only part that's actually our answer, is the bottom left part of our graph. So if you need to shade both of those first and then figure out where your answer is, that's fine. You may be able to just look at it and think, okay, less than both of these lines, I know where that is, that's, you know, in the bottom left, and then go from there. It's a little trickier when one is less than and one is greater than. That is easier if you go ahead and shade and see where they overlap. On to conic sections. So if we have a parabola, what we care about is the vertex and which direction it's opening. And so the vertex on these has to do with what's inside of our parentheses and what's at the end outside. So when we find the vertex, whatever's inside, if it's x inside, then what's inside is telling you your x value. So on number 3 here, our x value is +1. It's a positive because this whole section, if something's in parentheses and you use it at some point, you're going to change the sign. So this is a +1, but what's outside we don't change the sign of, so it's a +2. So the same thing happens for the vertex on 4. The inside is with x, and so it's telling us the x value is 2. The outside is -10, so that's our y value. Since these are both y equals, we also look at the number in front of our parentheses, and y equals means it opens up or down. A negative would be down, a positive would be up. So the fact that it's y equals -3 in front, it means that we have this opening down, and the fact that this is a +2 means that this opens up. Then when it's x equals, everything is kind of backwards. For instance, our vertex, inside our parentheses we have y, and so the 7 here is telling us that our y value is -7, not our x value. And that means -4 is our x value. So it's switched around as far as what's telling you what. But if you remember that what's with y tells you your y value, then that should help. So here, what's inside with y is 6, so our y value is +6. Our x value is -10. Just in general in math, by the way, when things are in parentheses, they tend to be opposite. And so you could call that being part of the super secret opposite society, that these numbers are part of this society that automatically changes signs if you wanted to, but you don't have to if that's not your thing. The other thing we want to do on these is say which way it opens. So like here, x equals +4. The positive direction for x is to the right, so this opens to the right. And over here, the -2 means this opens the negative direction for x, which is left. And whenever I say those things, I'm talking about like on the x-axis and the y-axis. You have positive numbers on the right, negative numbers on the left. So if it's positive, it opens right. If it's negative, it opens left. The same is true for y. Positives are at the top, negatives are at the bottom. So it tells you the direction of opening. Now let's use some information to find the vertex form equation of some circles. And so the fact that this says vertex form, that may not be something that your teacher uses, but if you think of vertex like it's the most important part of whatever graph we have, then in this case our vertex would mean that it's going to show us what our center is. So what we do is we take our center, 10, -8, and we take the radius, which we don't know right now, and we plug those into our normal equation, which looks like this. X minus, that's not going to be an h, so not b, h. All right, x minus h squared plus y minus k squared equals r squared. So we just want to fill in our center, which is h and k, and our radius, which if we know that the diameter is 14 and that diameter is all the way across, our radius, which is halfway across, would just be 7. So we're going to fill this in, x minus 10 squared plus y plus 8 squared equals 7 squared. Now, this is what's happening here again, where like the inside of our parentheses, it changes sign. That's because this is x minus h, this is a positive 10, that makes it x minus 10. On the second part, it changes the sign. It was y minus k, which makes it be y plus 8 instead of y minus 8. And then we would rewrite this, or instead of writing 7 squared in the first place, actually, we could have said, I know what 7 squared is, it's 49. So you can either rewrite it and write 49, or your teacher may be fine with you leaving it, and that's cool, but this is our equation for this circle. On 8, we have a graph, and we're going to use that graph to figure out the equation, and so we still need the same things. We need to know what is the center of this circle and what is the length of the radius. The center, it looks like, is at -1, -3, I mean. And the radius is actually a little bit trickier if you're not paying attention, because because this is not 2, which you might have thought at first, because look up here at our scale. It takes 2 squares to get to -1 or to +1, or between any two numbers, and so that means our radius is just 1, not 2. So then we fill into that formula and get x plus 1 squared plus y plus 3 squared equals 1 squared, or we can just leave it as 1 since 1 squared is 1, and that would be our answer. Then we've got ellipses, or ellipses. I'm not really 100% sure what the appropriate plural is on this, but we'll just go with it. To find the equation that we need, again, vertex form is not necessarily the correct word for this. It's actually standard form for an ellipse, is that we can see what the center is and what the major and minor axes are. And so what we need is the center, and so if it helps you to cut the ellipse in half both ways, if that helps you find the center, then that's a good idea. If I cut it in half each way, I should intersect in the middle of my ellipse. That center point is at 3, 2. And then the other thing that we need to know is our major and minor axis. And so our major axis is how long it is the longer direction. So up and down is taller than we are wide, and that's a length of 10. So our major axis is 10, and because it's up and down, we're going to use that in a sec to tell us what should be underneath y. Our minor axis, I forgot what min stood for. A minor axis is the other way. It has a length of 6, and since it's left and right, that would be an x value, or what's underneath x. So we're going to plug this into our standard form for an ellipse, which, if you don't know what our standard form for an ellipse is, it's similar to a circle, except that we have fractions, so that makes it look not so similar. But the bottom of our fractions is kind of like telling us our radius, except since an ellipse is not the same both directions, we would have two different numbers on bottom. If a squared and b squared were ever the same, what we'd really have is a circle. But they're not the same. So we can plug in our center for h and k like we did with circles. A squared is going to come from us figuring out what whenever you figure out what's on the bottom of this, you take your major axis and your minor axis, you half and square it. So I'm going to take 10, divide it by 2 and get 5, and then square it and get 25. That's what's going to go underneath y because it was up and down. So if we're like drawing this out, the y goes here and the x goes here, and so underneath y is 25 because we halved and squared the 10. Underneath x, since it's left and right, we're going to half and square 6. So we half it and get 3, we square it and get 9. Then we just need to fill in our center, x minus 3 squared plus y minus 2 squared, and that would be our answer. Same kind of thing is going to happen on number 10. Actually, the exact opposite kind of happens. Like we're given the opposite. Now we know what the equation is. Excuse me. We know what the equation is, so we're going to figure out what the center is. That part, once you get the hang of finding these, the center is no big deal because you just have to remember the x value is what's with x, the y value is what's with y, and I'm going to change the signs if it's in parentheses. So this is -5, -3. The major axis, if I didn't say this before, the major axis is the bigger one, the minor axis is the smaller one. And so the 144 is going to give us the major axis. Since over on this problem we had to half it and square it, if we try to do that on this problem, then what we get is going to be way too big of a number for it to be an ellipse that we could actually draw on a graph. Even so, it might be kind of a big number, but not as big. So if I want to do the opposite of half and square, the opposite of squaring is a square root. The opposite of halving is to double, so that's what we're going to do. And so hopefully like it occurred to you to square root it because both of these are perfect squares. So you square root 144 and get 12, which is an awesome number to get. You square root 81 and you get 9, which is an awesome number to get. But our major and minor axis aren't 12 and 9, you have to double those. So the major axis is 24 and the minor axis is 18, because again, the major axis is the longer one. Now hyperbolas. So for hyperbolas, they're really similar actually to our ellipses as far as like what we need to know and how we write the equation. The graphs look super different because an ellipse is basically an oval. A hyperbola, it's kind of like you're taking an ellipse, cutting it in half, and then reflecting them out either direction. And that, I mean, that's a special looking ellipse, I guess. But that's the basic idea. So what we do when we draw it, and we'll draw some later, is we draw a box that if this was an ellipse, this box would really be an oval. And so we're going to use that info as far as how tall and how wide this box is to help us figure out the equation of a hyperbola. We're also going to use the center here, which is at 1, 0. We're going to use the fact that the actual pieces of our hyperbola are on the top and the bottom. When it's on top and bottom, that means that in our equation, y should go first. So on 12, where it's not top and bottom, it's left and right, x will go first. And the main difference with a hyperbola, so there's two basic ways to write this. You could have x first. And the main difference between it and an ellipse is this minus sign in the middle. Or you could have y first, which is what's going to happen over here on 11, is that we'll have y minus k squared over, and it doesn't really matter whether you put a squared or b squared. Technically a squared is supposed to go with our major axis, and so it's supposed to be the bigger one, but it's not super important. All that matters is that you know the bigger one the bigger number gives you the major axis, and the smaller number gives you the minor axis. So the other thing we need, now that we have the general equations to use, is we're going to figure out the major and minor axis length. So because I drew the box, and you could kind of see the box already on this one, you at least for sure know where the bottom and top is, because that's touching the hyperbola. As far as left and right, since they had the lines drawn, it had to go through the corners of our box, so that helped us figure out how wide it was. So we want to write this out. Y is first because it's on top and bottom. So we'll have y minus, now because y is first, we're going to put the y value first, not the x value. And then do x minus 1 squared. And it's just part of the formula that we have a minus in between and a 1 on the right side. We're not getting that from anywhere in particular, except just knowing that that's the way these equations are supposed to work. Underneath, we need the major and minor axes to help us out with that. So our major one is up and down and is is 10. So major is 10 and is up and down, so it's telling us what to put under y. Our minor axis is is left and right and is 4. It's telling us what to put under x. We're going to half and square, so 10 is really giving us 25. 4 is actually giving us 4, because if you half it and square it, it's 4 again. Now, if you thought whenever I wrote y minus 0 squared that, oh, that's silly, we should have just wrote y squared, you're absolutely right. It's more mathematically correct, in a way at least, to put y squared over 25 without the parentheses, and depending on your teacher is how picky they are. They may be fine with the first answer, or they may want you to change it to the second answer no matter what. You just have to know your teacher and that kind of thing. Go ahead and see if you can start number 12 now that we've done that. See what you can figure out, like the center and all of that, and then we'll get started in just like 5 seconds. And so if you need more time than that, pause the video. So we need the same information. We need to know that the center is at 1, -3. We need to know that it's on the left and the right, which means that x is first. We need to know that the major axis is 6 wide and is telling us about x because it's left and right. The minor axis is 2 tall and is telling us about y. And so we're going to put all of this together into our formula. Since x is first, I would have x minus 1 squared over something minus y plus 3 squared over something equals 1. You're going to half and square 6 and 2, so halving and squaring 6 gives you 3 and then 9. Halving and squaring 2 gives you 1 and then 1. This is another case where it's technically better for us not to write it as over 1. It's like more mathematically correct in a way. So we do x minus 1 squared over 9 minus y plus 3 squared without it being a fraction. And so again, depending on how picky your teacher is, they might want you or strongly encourage you to write it the second way unless you want points off. And so that's something you should find out before the test. So on 13 through 16, we're trying to figure out which equation is which kind of conic section. And so one thing that might help you is that we don't actually need all of this. All we need are the squared terms to figure this out. So you can just mark out the rest if that would help you not get distracted by whatever else is going on. You just need x squared and y squared, if there even is an x squared and a y squared, because on 16 there's not an x squared, so you'd get rid of everything but y squared. And 16 is actually the easiest one in my opinion to identify once we do that. If you have one that only has one squared term, that is a parabola. And you can go back and look at the parabolas we've done so far and hopefully say, okay, yeah, that makes sense. It was either x equals or y equals something squared, and that means there should only end up being one letter that's squared. The next easiest, in my opinion, is to look for the one that has the same number in front of x squared and y squared, because that's a circle. Technically, we could have like 2x squared plus 2y squared, and that should still give us a circle. Usually it's just regular x squared and regular y squared, but all that really is required is for them to be the same, and in fact to both be either positive or both to be negative, if you really want to get technical. If we were subtracting here, it would be a hyperbola, not a circle. But since it's positive x squared and positive y squared, which is the same as each other, this is a circle. Now 14 and 15, which we have left, the difference between an ellipse and a hyperbola, if you look back at the difference to what we wrote, an ellipse is going to have just addition with x squared and y squared, or the same sign on both of them, but a hyperbola has to have different signs to create the subtraction in the middle of our fractions. So our ellipse is the one that has 4x squared and 9y squared, and then our hyperbola is the one where we're subtracting. Now it could have been switched around. We could have had y squared minus 9x squared, and that would be fine, but one of the two of these has to be negative, but not both. We're going to sketch a graph. It even tells us what this should be. It's a circle. And so to draw a circle, if you just think off the top of your head, what do I need to draw a circle? We need the center and radius. And so inside of this parentheses with x is 2. So that's our x value. If there's not parentheses with y squared, that means our y is 0. The square root of the right side gives us our radius. So we want to go right 2 and not up or down to 0, and then go 2 every direction, because that's what our radius means, is that we're going 2 everywhere. And then you want to, this is going to be bad, I can tell, but you want to draw this in as like a circular fashion. It's really easy to accidentally make these look like diamonds or rounded diamonds because of us knowing 4 of the points that we want to hit. Personally, for me, it's most important that you plot the center and the 2 each direction, and then I try not to judge too harshly if you can't draw a very good circle. But again, teachers vary in pickiness, so know your teacher and let that guide you with how good you have to draw. Here's an ellipse. So again, we want our center. This time x squared doesn't have a number, so it would be 0, and this would be -3 for y. Our major axis is the bigger of these two numbers, but we've got a square root and double, so our major axis is 14, and what matters is that that's underneath x, so our left and right has to be a total of 14. Our minor, we square root 9 and get 3, we double it and get 6, that was underneath y, so it's telling us how much to go up and down. This is an ellipse, so it's an oval. We're going to start at 0, -3, and then we're going to go left and right 7, so that we have a total of 14, up and down 3, so that we have a total of 6, and then we're going to try to draw this so that it looks like an ellipse. And again, hopefully your teacher doesn't mind it looking kind of like a potato like mine does. Again, what's more important is that you've marked it out correctly, each direction. Hyperbolas are similar to ellipses. We're going to start them the same way. So our center on this first one is 0, -1. Our major axis is square root of 16, which is 8. No, square root of 16, which is 4, and then you double it and get 8. That's what's underneath y, so it's telling us how tall to make our box. Our minor axis comes from the 4, square root it and double it, and you get 4. Since x is first, we're going to draw on the left and the right side. So put it all together on your graph. You're going to plot 0, -1 for your center. Since our major axis is 8 and has to do with y, we're going to go up 4 and down 4. And since our minor axis is 4, we're going to go right 2 and left 2. And we draw a rectangle that basically it ends up being 8 tall and 4 wide. We draw asymptotes through our corners of our boxes. And so I like to make asymptotes be dashed lines or dotted lines because we're saying, like, that's just kind of something we do. Your teacher may want you to use solid lines. I don't know. I think most people use dashed lines like this. And then, since it's on the left and the right side, you go to the box on the left side in the middle, and it's going to touch your box, and then it's going to go out almost like, it almost looks like a parabola, but it's going to head towards your dashed lines, never crossing them, because that's what an asymptote is a line that prevents our graph from going across it. And then on each side, it's supposed to be like kind of symmetrical, like you shouldn't have one that looks like super different from the other, but that can be hard. As you can see. But it should be on the left and the right side. It touches your box in the middle of the box on the left and the right side and goes out from there. Notice it doesn't touch the center. It doesn't go inside the box at all. It's almost like the inside of the box is off limits. So it's touching the edges of the box, but it's not going through. Unfortunately, this is another x squared first. We could pretend it was y squared first if we wanted to, or you hopefully could find a y squared first example somewhere in like notes you have or worksheets if you're in a class for this, but we'll go ahead and do it with x squared first. The center is 0, 2. Just remember, if it was y squared first, that would tell us our y value and then our x value for our center. Our major axis is the square root of 25 doubled, so that's 10, and that's underneath x, so it's telling us our left and right. Our minor axis is the square root of 9 doubled, which is 6, and that's under y, so it's telling us how much to go up and down. So from 0 to, we want to go left and right 5. We want to go up and down 3. 1, 2, 3. 1, 2, 3, and draw your box. And so one thing that is helpful with this being x squared first again is to notice that it wasn't that our hyperbola showed up on like the bigger or smaller side. It has to do with which variable is first. And so on number 19, it was on our bigger side, which was left and right, but on 20, our bigger sides are up and down. That's not where we're going to draw our hyperbola. We're going to draw it on the left and right side, because in our equation, x squared came first. So we go to the edge of the box in the middle and we draw. They kind of look like parabolas, but they typically are wider than parabolas, I feel like. I mean, you can have really wide parabolas, but they're not the exact same. You want to make them head toward the asymptotes each direction. Our final conic section question, and so after this one will be matrices, and if you're just interested in conic sections, then you could stop after this problem, is we are graphing a parabola, and it's in vertex form, so if you're allowed to use a calculator, you could obviously use that to help you, but it's really almost easier, as long as you know what you're doing, to just look at it and do it by hand. Inside with x is 6, so it's -6, comma, outside is -4. Remember, what's in parentheses changes signs, what's outside parentheses doesn't. It's y equals a +2, which means it's going to open up. So I'm going to come over here to -6, -4, and I know it opens up. So there's two ways I can do this. I can start plugging in numbers for x to get points, or depending on how many points your teacher wants you to draw, there's a really easy way to get 2 more points and then call it good. All I have to do to know where I go from here is know that it's going up, and then look at this number. If that's a 2, it should go up 2 to the right and up 2 to the left, because parabolas have symmetry, and then you can draw your parabola. If your teacher wants more points than that, then from there you could plug in -4 up here. So you could say y equals 2 times -4 plus 6 squared minus 4, and figure out what that is, what the y value for that is, and I think it ends up being 4. And so at -4 it should be 4. And then the same thing can be said about -8 over there on the other side, because we have symmetry. And so we can make this be an even bigger parabola, because now we know more about it. So it depends on your teacher. If your teacher wants a whole bunch of points, then you're probably going to need to plug in some numbers. If they're fine with just 3, you can just look at the equation. There's not an example on here of if it is x equals, so I'm going to give you one real quick that if you want, you can do it on the same graph, because I'm going to purposefully make it to where they don't overlap, or at least not too much. We'll see if what I am trying to do actually works out. So if it's x equals, and I want to sketch it, I'm going to do the same thing and find the vertex. But now my vertex, the inside is telling me y is +5. The outside is telling me x. So this is at 7, 5. And the -3 and the fact that it's x equals is telling me to go left 3 for my next points. One of the issues with this is that you can't easily plug this into your calculator, because your calculator wants y equals, not x equals. And so that trips a lot of people up and makes it to where it's actually a way more work in a lot of ways to try to make it fit in your calculator. If you need more points than just this, what we do is we plug in numbers again. But this time we're going to pick y values to plug in, like 7 or 3, and we plug them in over here. 3 is smaller, so let's do that. You plug them in for y, which means it's going to give you your x value. So that would be -5. So when you plug in 3 for y, you're getting -5 for x, because this is a really skinny parabola in a way. And then you can connect in a smooth curve. So they did overlap a little, but not a whole lot. And so again, it depends on how many points your teacher wants as to how far you need to take that. Our matrices that we're going to go over, which is from our previous test, if you're adding and subtracting matrices, it's easiest just to make them all addition. And I can do that if I change this sign to plus. I have to distribute it into the matrix that's after that, not into all of them. That negative is just affecting this middle matrix, and so it makes it a +5, a -6, a -5, and you can put -0, but 0 is not really positive or negative, so it doesn't really matter what's in front of it. Then what you're doing is kind of like terms, because you want first element plus first element plus first element, which would give us 11. And then we want the second element and the second element and the second element, which gives us our second element. So -2 plus a -6 plus 5, which is -3, and so on. So you'll do the third element in each, which gives you -10, and then the fourth element in each, which is +10. The only way that this would be undefined, if all we have is addition and subtraction, is if we had different sizes. So in order for us to do this, all of these had to be the same size matrix. That's not true when we start multiplying matrices together. They don't have to be the same size, but as long as we're just adding and subtracting, we can check based on the size to see whether we can do it or not. On this problem, the order that we do this in does matter, just like it pretty much always does in math. There are parentheses around these two matrices, and so that's what we're going to do first. And again, I would rather add them than subtract them. So I'm going to change all the signs in my second matrix. -6 plus 6 is 0, 6 plus 3 is 9, 6 plus 1 is 7, 1 plus a -5 is -4. And then we take that answer and we times it by our other matrix that we haven't done anything with. Now, matrix multiplication is most often not something people are a fan of because it's a little bit on the complicated side. So let me walk you through it. We want the rows of the first matrix and the columns of the second matrix. So I'm going to look at the 0, 9 and the 1, negative 5. And I'm going to multiply each first thing together and then add it to the second things together. So what that means is 0 times 1, because that's the first part of my row and first part of my column, plus 9 times negative 5, because that's the second part of each of them. And I'm going to add that together, and that gives me my first element. It gives me negative 45 in my top left spot here. Then I'm going to do my first row, but I'm going to do it with the second column. So I'm going to use 0, 9 again, but now I'm going to use 5 and negative 4. And so if you pretend like these are on top of each other, your answer goes where these overlap. They overlap in this spot in the top right corner. We're going to do the first and first, so 0 times 5, plus the second and the second, so 9 times negative 4. And then we're going to do the same thing, and that gives us negative 36 in that spot. We do the same thing now with the second row, and we're going to do that with each of the two columns. So we're going to do second row, first column, and then we'll do second row, second column. And you may not need to write all this out to be able to figure it out. You may be able to do it in your head, or you may be able to do it in your calculator or whatever, and that's fine. But if you want to write it out, that might help you. The second row, second column will be 7 times 5 plus negative 4 times negative 4. And so that adds together to get 51. So this is our answer. And that's kind of long and takes a decent amount of work, and it does require you also to be very careful because there were a lot of places that we could make math errors to make us not get the right answer. So that's why a lot of people aren't really a fan of matrix multiplication, to be honest. On 24, we have parentheses again, so we want to add these together first. And we technically don't have to add them together first. The negative 4 on the outside, we just need to make sure that we know it would have to distribute to everything inside the parentheses. So I think it's easier to add them together first, and then to distribute this negative 4, so that we get positive 4, positive 28, and negative 12. But if you multiply negative 4 into all of them first and then add them together, you should get the same thing. Because you're distributing, which is an okay thing to do. But if you only put the negative 4 in one of the matrices and not both, then that's not correct order of operations. And finally, we've got 3 matrices again, but we have addition and multiplication. We have to say, okay, which of those goes first? And it's the same as if these were numbers. You multiply, as long as there's not parentheses, you multiply before you add. So we're going to do these two together first and then take our answer and add it with our original matrix. So you may be wondering how to do this since they're not the same size, and you may be thinking, oh, well, that makes it undefined, so we don't have to do that, right? Well, no, what matters is that there are 2 things in this row, there are 2 things in this column. If those match, then we can multiply them together. If they don't match, if we had 3 numbers in our row and only 2 in our column, then you can't do it. So we're going to do 4 times 1 plus 2 times 4. Then we're going to do 2 times negative 1. No, what am I doing? I didn't mean to do that. So that's our first spot. Our next spot is going to be 4, 2, negative 1, negative 5. So we're going to do 4, negative 1 plus 2, negative 5. And then we'll end up with 3 rows here because we have 3 rows. So I'm going to do 1, 6 with 1, 4. And then I'm going to do 1, 6 with negative 1, negative 5. and then we have to do the last row. So we'll do -6, -2 with 1, 4. So -6 with 1 and -2 with 4. And then -6 with the second row, column, -6, -1 plus -2, -5. We figure out what all these numbers are. We should get 12, -14, 25, -31, -14, and 16. I said 14, but I wrote 15. LOL. And then what we do is we add, remember, this other matrix to that. So -1, 5, 4, -4, -5, 6. We're going to add these together. So you do the top left element with the top left element, and that goes in the top left element spot, and so on. So we should end up with 11, -18, 30, -36, -10, and 22. And that should be our answer. So this has been conic sections with a little bit extra from good old systems of equations and matrices. Hope you've enjoyed this review.